Okie doke, let's do some operations with polynomials. The reason 29 and 30 are on there is almost more to do with this than with these problems. But I want you to realize that b plus 2 squared is b plus 2 times b plus 2. So you have to treat it just like you do 29 and 30. So you're going to do, you can distribute, you can think of FOIL where we do the first from this parentheses times the first of this one, the outsides of both parentheses, the insides, and the last. So you should end up with 4 terms. 2 terms times 2 terms is 4 terms. So 5v times 6v makes 30v squared. 5v times 5, 25v. Negative 1 times 6 is negative 6v, and negative 1 times 5 is minus 5. Okay, we've got 30v squared, and then we've got 2 terms that are like terms. 25 minus 6 is a 19v minus 5. And that's all there is to number 29. But you can't forget the outsides and the insides. That's what people do, and it always makes things go poorly. All right, number 31. This time we've got 2 terms here multiplied by 3 terms over here. Well, if 2 terms times 2 terms gets us 4 terms, this should give us 6 terms. So knowing that when we go in, to make sure that we do it correctly, 4a times 5a squared gives us 5 times 4 is 20. A times a squared is a cubed. 4a times 4a is 16a squared. 4a times negative 7 is negative 28a. There's 3 of our terms. Then we've got negative 5 times 5a squared, negative 25a squared. Negative 5 times 4a, negative 20a, negative 5 times negative 7, 35. We got some like terms again. Okay, so we got 20a cubed. That's the only a cubed term, but we have 2 terms that have a squared in them. So 16 minus 25 is going to be a negative 9a squared. And then we've got 2 terms that have just a's. Minus 48a and then plus 35. So it does simplify down into 4 terms, but it had 6 after we multiplied it out. All right, let's do a little bit of addition and subtraction. I'm going to do 33 because 33 is the one that gets us. These are written in no particular order. They're not written in standard form. But what we really need to pay attention to is this minus sign refers to all of this. We're taking away all of it. 5p, taking it away. Negative 4, taking it away. What does it mean to take away negative 4? It really means to add 4. So I'm going to rewrite the first parentheses and the first set of terms in parentheses. And the reason I just wrote them like that is because all that's happening there is addition and subtraction. So the order of operations would be telling us to make sure we do all the multiplying or something, or everything out there first, or everything in there that we can first, but there's nothing we can combine. And then the next set of parentheses, again, nothing we can combine, but we can do this minus the subtraction. Minus 5p minus negative 4 is actually plus 4, and minus negative 6 is plus 6p cubed. We got negative 8p to the 4th. We're going to put this in standard form. I have 2 terms that have p cubes in them. So that's 1p cubed plus 6 more makes 7. I don't have any p squareds. I do have a negative 5p. And then we have 5 plus 4 is 9. I'm going to jump down and do 36. Just so I have a little more room there. The 36 just has an extra set of parentheses, more time consuming, but not more difficult. So again, 1 on the outside, if we multiply that in there, it doesn't change anything. So we don't really need those parentheses. But we do need this set because we're going to subtract all of this, which means instead of 2, it's minus 2, minus 7n minus 5n squared. And then here, we're going to add 6n squared. We're going to add 5n. Time to combine some like terms. We got a bunch of them, a bunch of n squareds. So -2 minus 5 is -7 plus 6 is -1n squared. Then we've got n minus 7n, that's -6n, plus 5n is another -n. 6 minus 2 is 4. That is operations with polynomials. Next up, graphing rational equations and functions. Whee!